Hello, my name is Olivier Gerbault. I'm a plastic surgeon in Paris, France, and it's my pleasure to introduce a paper we wrote in the 2016 January issue of Aesthetic Surgery Journal with Roland Daniel and Aaron Cousins on the use of piezoelectric instruments in rhinoplasty. First, what is piezosurgery? Well, piezo instruments use the piezo transducer properties to convert electrical energy into extremely rapid mechanical vibrations. Those ultrasonic vibrations selectively create a cavitation effect on the hard tissues, dissolving the bones and the hard cartilages. It's therefore possible to cut, to rasp, or to trim hard tissue while leaving the soft tissue untouched. I've been working on the development of ultrasonic rhinoplasty for 3 years after having realized that we were lacking control on bones reshaping in rhinoplasty, whereas cartilage could be accurately reshaped since the advent of cartilaginous sutures and grafts. We must also consider that the instruments we are using for rhinoplasty were designed more than a century ago, and that they may be too aggressive for the delicate nasal bones. Finally, whatever the approach, close or open, bone surgery of the nose has until now been done blindly. Well, I have adapted the use of piezosurgery to rhinoplasty in 2 ways. First, by designing special piezoelectric instruments for rhinoplasty. Second, by doing systematically an extended subperiosteal dissection of the whole bony vault to assess the bone characteristics and to allow an easy use of the piezo instruments. All this can be done safely because piezoelectric instruments have a very gentle effect on the bones, unlike the mechanical instruments. Therefore, they don't destabilize bones the same way as mechanical instruments do. Bones are less likely to collapse in the airways even after a complete osteotomy without any area of green stick fracture when piezoelectric instruments are used. This bone stability has been observed in the cadaver dissection performed with different rhinoplasty surgeons and described in this article, and it has encouraged us to use the extended dissection clinically. We described in this article the way we perform home production, osteotomies, bone smoothing, but also ultrasonic rhinosculpture, which is a new technique consisting of debulking the bones without breaking them. That means that when the bony vault is not too wide, incremental ostectomies can be performed to narrow the bony vault. The nose can be narrowed without breaking the bones. Now for the readers, I would like to stress the following point. The surgical sequence is critical to achieve a predictable result. The bony hump must be first incrementally removed at its medial and lateral aspects. Then, osteotomies are done if needed, that is, if the bony vault is significantly too wide, beginning by the low lateral osteotomies. And what is striking then is that the bones can frequently significantly move inwards after only lateral osteotomies. But if bones don't move enough, transverse osteotomies and, if necessary, medial oblique osteotomies are done. After every osteotomy, the bone's edges are smoothened by a diamond rasp. Beginning the rhinoplasty by treating the bone is also critical, in that it allows the middle third spring effect on the bones to be adjusted later. Piezosurgery has numerous other advantages in rhinoplasty, especially for the middle vault stability or to relocate the septum accurately. Even ultrasonic septoplasty allows septal reshaping without removing too much septum and avoiding twisting motion to remove parts of the septum. I hope this article will interest you and stimulate your minds with these disruptive concepts. Thank you very much.